Hey guys, now we're up to probably the most difficult question that I've found in the entire test. So I really want to explain to you my steps in doing this, and I hope I get a little bit more confident along the way. So for me, number one, we find the x and y intercepts, if we can. It isn't that important right now, but if we can, we do it. Secondly, what we do is we find the stationary points through differentiating it. And thirdly, what we do is we determine the nature. So we determine the nature, which is either concave up or concave down, either through a table or we can actually just do the d2y and then dy2 method. So the second differentiation method. It's either that, either the table or the second differentiation. And after that, all we have to do, number 4, is we find points of inflection. By making d squared y over dy squared, the second differentiation, equal to 0. Okay, so now let's do this. Let's actually just let's just find it and try and do this. So now we know that the y-intercept, just quickly solve it over here. We make everything equal to 0, so 3 there, 0 minus 0 plus 0. So y-intercept, y is just 0. And x, we can't really solve right now, we won't really bother. So we're just going to pretty much differentiate this and see how we go. So I'm going to rewrite the actual question, and the question was, if I can recall, the question was y equals 3x to the 4 minus 44x to the 3 plus 144x to the 2. Okay, now what we do, we just differentiate it. We want to find the stationary points. So f dash y equals, okay, so we have 12x cubed minus, so 44 times 3, sorry, I'm just checking this into my calculator. We have 132x squared plus 288x. So now we have this. We can make this equal to 0 to find the stationary points. So now we've done this, we can just try and solve. So just by looking at it, I can tell that 12x is divisible, and we can factorize it out. So 12x divisible by 288 is divisible by 12x, 132 is obviously divisible by 12x, and so is 12x itself. So I can make it so 12x comes out, and we can just write this. We can write x squared minus, so 132 divided by 12, we get 11x over here, and we can just make it plus 288x divided by 12, 288 divided by 12 is 24, so 24. Now it makes it even more simple. So we've got 0 equals 12x, and now what we can do is that we can even factorize this further. So here we go. What actually adds times to give 24 and adds to equal negative 11. So obviously it has to be two negative numbers, since this has to be negative and this has to be positive. So which two negative numbers add to each other to equal negative 11? So let's have a look at it. Negative 5, negative 6? No, that wouldn't work because we need to get 24. What about negative 8 and negative 3? So if you add negative 8 with negative 3, you get negative 11x. And if you times negative 8 and negative 3, you get 24. Perfect. That's exactly what we're going to use. So we get x minus 8, x minus 3. Now I should just put this all in brackets because it's actually being times by the 12x. Now it won't be that hard. We can actually find our stationary points, since if that was equal to, suppose, 0, then this entire thing would be 0. So first one is x equals 0. Next one is x equals 8. After that, it's x equals 3. Now, these three are our stationary points. Well, not quite yet, that's just the x values. Let's sub them all into the original equation to find the full points. So let's see. We've got, so let's sub it into the original equation, not the actual differentiated one, so we want to sub it back into this. So here we go. We have 3 to the 0 power 4 minus 44 to the 0 to the 5 plus 144 to the 0 to the 2. Now, obviously, you know that that equals 0. So, the first stationary point is 0, 0. So, let's just say that's our first stationary point. Then we've got x equals 8, so let's sub this in. 3, 8 to the 4 minus 44 to the 8, 5 plus 144 to the 8, 2. Now, I'm just going to chuck this into my calculator and see what I get. Okay, so I get minus 1024. So that is 8. Yep, 8 minus 1024. So that is basically it for that one. And let's do the next one. So 3 to the 3, 4 minus 44, 3 to the 5 plus 144 to the 3 to the 2 equals. So we will have 3 to the, just putting that into my calculator. Yep, 351. Okay, so these are our three stationary points. Now we actually have to see if the concavity changes in these points. We have to determine their nature. So if we refer back to this, do you know how I said find stationary points and determine their nature? We can either use the table or d2y dy squared 2. So the easier option in this is obviously this. So if it's an easy function to differentiate twice, just use this method because it's going to get you there quicker. Doing the table for 3 stationary points is going to take a lot longer. So let's just do this method. Let's find the second derivative. So here we go. We have, I'm just going to use another color, perhaps grey. So f double dash y equals 36, because I'm just differentiating this, 36x squared minus 132x squared, so 132, okay, equals 264 x plus 288. Now, since this is pretty ugly, what I'm actually going to do is see if I can make this a bit simpler, but right now I can't, but doesn't matter. What I'm going to do is I'm going to sub my stationary points into this and find their nature. So I want to know if they're concave up, concave down, what's actually going on. Let's figure this out. Okay, so for the first one, x equals 0, we've got x equals 8, and we've also got x equals 3. So let's solve this for the first one. Okay, so we just sub it straight into this. We sub the stationary points into the second differentiation, second derivative. So we've got 36, 0 squared minus 264 to the 0 plus 288. Now, we end up with 288, obviously. Now, 288 is bigger than 0, therefore it has to be concave up. The smiley face. And hence, just think about it, if I had this graph, and if it was concave up, right, what am I going to get? I'm going to get a minimum. Okay, sweet. Now we can move on to x equals 8. So 36, 8 squared minus 264, 8 plus 288 equals, so into my calculator, straight in it goes, it equals 480. So once again, 480 is bigger than 0, and hence it's concave up. So anything bigger than 0 is concave up, anything smaller than 0 is concave down, anything equal to 0 is basically a inflection point. So now, we can pretty much just say again, it's a minimum. Okay, moving on to x equals 3. 36 to the 3 squared minus 264, 3 plus 288 equals. Okay, for that we end up getting negative 180. So since it's a negative 180, 80, my bad, it is obvious that 0 is bigger than it. So therefore it has to be a concave down. And now that means that we've found that it's a maximum. And I'll just show this on the graph in a second. So if you had a graph, something like this, and you had minus 180, so it's concave down, so it's something like that, we know that this is a maximum, right? So for that one it's a minimum, for this one it's a maximum. Okay, perfect. Let's keep on going. Alright, now we've found all this. What do we do now? Well, let's just plot it all out. So let me just do that for you now. I'm going to plot it all out and I'll just show you what I mean. So we've got the points. These are the stationary points, as I said. We've got 0, 0, and at that point it is concave up, which is a minimum. We've also got 8 to the 1, 0, 2, 4, which is also a concave up minimum. And then adding on, after that, we have 3 and 351, which is a concave down, which is a max. Okay, awesome. Now we've got these 3 points, and let's see if we can find the inflection points, which is our next step. Have a look here. We've said that we wanted to determine the nature. We've done it. We've got the 3 points and we've determined their nature. Now, for number 4, we want to find the points of inflection by making the second derivative equal to 0. Here we go. Let's just do this now. Okay, so our second derivative was 36. I'll just write this out in a different color. So you have 0 equals, finding the inflection points, 36x squared minus 264x plus 288. Now, honestly, you can't really do much with this except, let's have a look. Let's see what I can actually do with this. I could perhaps divide it all by 12, so let me just take a look if it's all divisible by 12. 36 divided by 12, obviously yes. 288 divided by 12, correct. 264 divided by 12, 22. Okay, so we could divide it by 12. Okay. But honestly, the best option for this, since it's so complex, I'll just say sub it straight into the formula, the quadratic formula. So here we go. You might need some memory refreshment for this, so I'm just going to write the formula out. So it's minus b plus minus square root of b squared minus 4ac all over 2a. So now let's just say a equals 36, b equals negative 264, c equals 288. So now let's do this. So negative 264 plus minus square root of b squared, so b squared is negative 264 squared minus 4ac, so we got 4 times 36 times 288 all over 2a, so that's just 236. So now let's just chuck this all into our calculator, I guess. We should end up with something like this. So we'll have a positive 264 plus minus square root of 69696, great number, 41472 over 2 times 36. So we can just simplify this further. Going down, we have 264 plus minus, well, the square root of that is just 168 over 236, so that's just 72. So now we can figure it out. What we basically have now is just 264 plus minus 168 over 72. So doing that inside our calculators, we can figure this out. So 264 minus 168 over 72. So that is equal to minus 164.8 over 272. 4 over 3. So the minus one is 264 minus 168 over 72 equal to 4 over 3. And we have 264 plus 168 over 72. So I'm just going to change that sign in my calculator. And I get 6 equals 6. So these are our two x values for points of inflection. Now what we want to do with these is strictly use a table and figure out what type of point of inflection they are, and if they actually are a point of inflection. So to see if they actually are a point of inflection, so like if it's changing concavity, we need to use this table. So here we go. Let's just figure this out. Okay, it's a lot of work, but it's worth it, trust me. Alright. So 4 over 3 is basically 1.3, so you can just write 1.3 really. It's two decimal points, 1.3, fine, no worries, not 6. Now I'm going to draw my table. Okay, sorry for the really bad drawing, it's just pretty tiring. Okay, so we have x here, and we have d2y over dy squared. So over here, let's just draw this. Okay, let's see what we can get. So we have 1.3 here, and what I recommend is just by going down by 1 point and going up by 1 point. So 1.4 and 1.2. Ignore this, we don't really need it, we just need 3. So what it's meaning is that if I sub 1.2 back into the differentiation, the second differentiation, so the second derivative, what do I get? Is it positive? Is it negative? What is it? Okay, so let's do this. So I'm just going to do this on the side here. Here we go. We know that 1.3 is 0, so that's obviously going to give us 0. There's no real point finding what it is. So here we go, 0. Because 4 over 3, 1.3 is a stationary point of inflection, 0. Understand? Okay, sweet. 1.2. Let's do it. So going back to what we previously found, our second differentiation was just 1 second. Let me just find it, so I don't have to scroll back up. Actually, I will. Can't find it. Anyways, second differentiation, second derivative was 36x squared minus 264. So just quickly gonna write it. So 64 x plus 288. So now we can just sub all these in. So 36 1.2 squared minus 264 1.2 plus 288. What did I get for that? I got, let me just sub all of this in. Okay, 1.2 squared minus 264 to the 1.2 and plus 288. Okay, so I get a positive. Alright, so let's just draw a plus sign here. I don't really need to give you the actual number, but it's a positive. Now I'm going to sub it all in with 1.4 and see what I get. Okay, so that's good news, I get a negative. What this actually means is that it's just, we can confirm that it's a point of inflection. Now we can do this for the second point, which is 6. So I'm just going to replicate this graph in my really crappy drawings. Here we go. So we've got x here, and the second derivative here. Okay, here we go. So we had 6 equal to 0. We can just use 5.9 and 6.1. So I'm going to sub it straight back into the equation, just like so as I've shown before. So here we go, 5.9 which is equal to a negative. Then we've got 6.1 which is equal to a positive. That's also good news, confirms that it's a point of inflection. Now, going back to this, we know that these two are point of inflections, and since we do know that, I think it's worth spending the effort finding the y value. Since we only have the x, we've got 1.3 and we've got 6, so let's sub it back into the original equation. Not any of the differentiations, but into the original equations. So I'm just going to write something. Sub points, point x from point of inflection back into orig formula. So that's what I'm going to do exactly right here. So what I've done is just going back, looking at the formula. We've got 1.3 to the 4 minus 44 to the 1.3 to the 3, and we've got plus 144 1.3 to the 2. Okay, that should equal 161.2 to 2 decimal places. Okay, awesome. We can do that for the other one as well. So 6 4 minus 44 6 3 plus 144 to the 6 squared, which equals negative 432. So now we have our points of inflection. That's beautiful. Now I'm just going to write them over here. So points of inflection, just a little summary. Points of inflection are, okay, so we have 1.3 and 161.2, as well as 6 and minus 432. So that's our points of inflection. Now we've come so far. All that's left really is just graphing it, believe it or not. So I'm just going to show you how to do that exactly. Okay, so this is stuff that we already know. We know that the stationary points are 0, 0, 8, and negative 1024, 3 and 351, as well as the points of inflection are 1.3 and 161.2, 6 and negative 432. Now that's all we need to graph this actual thing. We have to sketch it. That was the whole point of the question. So let's go down to our axes and plot all these points. So 0, 0, concave up. Now let's have a look. If it's concave up, I'm just going to plot this here. So 0, 0. If it's concave up, you can already draw a little concave up kind of thing, so you know it's concave up. So just draw that out from beforehand. It won't actually matter, and it'll help you actually graph it later on. So 0, 0, it's concave up. You got 8 and negative 1024. So 8 and negative 1024. Let's just say it's here. Now that was also a concave up. It was a minimum, so it has to go like this. So we can just plot it again, just a little bit like that. So just so we know. So it was 8, negative 1024. Okay. So now we have 3 and 351 left. So last one here, 3, 351. Okay. So 351. I'd say something like that. So that was a concave up. So just graphing it like this, so we know how it looks like already. So since it was like that, we can now just plot the points of inflection. So 1.3 and 161.2. So 1.3, 161.2 would be something like that. So that's the point of inflection. So 1.3 and 161.2. That's our point of inflection. Then we've got another one, which is 6 and minus 432. So 6 minus 432 would be something like that. So that's the 6, and now if you have a look, we've done everything we need to do, and you can tell that it's just connect the dots really now. So we have this could just keep on going. So this is just like that, and then we got, it goes to the point of inflection, As soon as it goes through there, it goes to there. As soon as it goes through there, it goes down, 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 and it goes up. And then now it just goes up. So that's it. That is our graph, and this is how it should look like. Now, it's probably a bit different in yours, but this is how I've drawn it, and it did fit in every single spot. So I'm just going to check the solutions to see if I was right, and let's just see if it worked out. Okay, so the solutions are pretty similar to this. It's just in a larger scale, so it looks a bit zoomed out. But that is pretty much the answer. You should be getting 4 marks for this as long as you've labeled your axes, you've written out all your points, and you've shown that these are the points of inflection, and that you have all the stationary points on there as well. So the main question just asked, the main thing it was asking from the question was showing all turning points and points of inflection. So you know that all points of inflection are these, and all turning points pretty much these. So that's it, guys. That's sketching graphs. That's all it is, and I know you can do it. So good luck.